Given the picture above, we will assume that we have a 13 kilogram block and a 6 kilogram block, and we're looking for the acceleration, probably the magnitude, assuming it's going that way. We're also going to assume that this part right here, frictionless, also Pulley, no mass, and therefore we just got this kind of like Atwood machine thing going here. So to find the acceleration, first thought should be something along the lines of summation of all forces equals mass times acceleration. So you draw some forces on the diagram. The way I like to do this is I'll do it like this. I'll say we have a force due to gravity. Now you think we also have a force due to gravity over here, but we have a normal force as well pushing up on the bottom of the box, and that kind of cancels each other out. There's another way of kind of looking at this where you analyze it in terms of tension, where you're like, well, you have a tension up here and tension up here, and that's totally true, and that's a more formal way of looking at it. But if you just look at all the net external forces that's being applied to this system, despite all the messiness here, all we're really going to have is this force gravity due to block B pulling down on the system. So when I do this sum of all forces here, I'm going to say that's just going to be force due to gravity on block B, which will be, I'm going to call this mass B times gravity. And then we're going to do, this is going to equate to mass times acceleration. But in this case, the mass here that's being accelerated is both A and B. So we have MA plus MB, kind of like this. MA plus MB, and this will give you a acceleration of the system. And then simplifying this, looking for the acceleration, we have mass B times gravity all over mass, wait a sec, did I mess something up? Yep, move that out of it. And mass A plus mass B, okay, looks good so far. And intuitively, we should be getting something that's less than 9.81 meters per second, because this block is, if this MB was just falling, then it'd be 9.81, but we have this, it's also accelerating this block MA up here, which is an extra mass that needs to be accelerated. So ideally, we should be getting something less than 9.8. We got, let's see, mass B is 6, MA is 13, 13 plus 6 times gravity, 9.81. You might try and cancel those out. Don't, because there's a plus sign right there. You can't do that. Go to the calculator. Let's see, calculator on. Let's do 6 divided by, I'm going to say 19, which is 6 plus 13, times 9.81, and we get 3.098. So, kind of, sort of, 3.0, move over slightly, 98. And so that's going to be in meters per second squared. So to kind of recap what we did here, clear this up. We have these two blocks. We want to find out how much they are accelerating. And so we're going to use the formula, sum of all forces equals mass times acceleration. All the net forces are going to be coming from mass block here, the mass B. And so that's going to be our mass times gravity. And then that's going to equal the mass, combined mass of the system, times the acceleration of the system. And then do some algebra, solve it, and we get about 3.1 or so. Hope that helped. See you next time.